Hello students, I am here with the topic projectile motion. In this video, we are going to discuss projectile motion as a motion in plane. Projectile motion is a form of a motion experienced by a launch object under gravity. As we know student, the motion of an object under gravity is also known as a free fall. Now let's understand why it called free fall. A kicking of a ball from the ground surface is an example of the projectile motion. Here, the ball gets launched in the air and take a trajectory like this. Here we can see student at every instant of a time, the projectile that is ball has a vertical as well as the horizontal displacement. Hence, we can say that the projectile motion is a two-dimensional motion. In order to specify the motion of the projectile at any instant of a time, we need to consider the coordinate system. As we can see student, in order to specify the position of the projectile, we need vertical as well as the horizontal component. Hence, the motion of a projectile is called motion in plane. Now let's discuss both this vertical and the horizontal motion independently. For that, let's consider coordinate system, where the vertical distance measured in a meter. Let a ball is launched from 1 meter with the initial velocity uy. At this position, the mg is the force, that is the gravitational force, acts vertically downward direction. As the object or the projectile moves vertically upward direction, due to the gravitational force which is act in the downward direction, the initial velocity uy go on decreasing. At a certain height, we observe student, the initial velocity becomes 0. So that we can say instead of initial velocity, that velocity we call as a final velocity. So the final velocity at a certain height of the projectile is 0. Now the ball start moving in a downward direction. When the ball start moving downward direction, the direction of a velocity and that of the mg, that is a gravitational force, both are in the same direction. As the ball reaches to its original position, it observes that the velocity of the ball go on increasing. When the ball reaches to its position from where it launched, it attained the same velocity of that of launching. From this, we can say student, the acceleration which is act on the ball is the vertical acceleration, hence it is denoted by ay, and that is nothing but the gravitational acceleration. Negative sign indicate that the gravitational acceleration decreases the velocity when it moves in a vertically upward direction. Now we can see student, the motion of the projectile is parallel to y-axis. Here I show you the separate upward and downward motion in order to distinguish you the direction of a velocity and that of the gravitational force. So for the equation of motion, I can write x is equal to 0. As we know student, the projectile moves with the constant acceleration, which is acceleration due to gravity, we can use the kinematics equation to find its displacement, velocity, acceleration and time. So for any instant of a time, if I want to find the position of the projectile, I use the equation s is equal to ut plus half at square. So for that given instant of a time, I substitute the value s as a y, and the initial velocity, which is uy, t is the time for which we are finding the position of the projectile, minus half of gt square, where the g is the acceleration due to gravity. Similarly, to find the final velocity, we have v is equal to u plus at. For that, we substitute vy, where the vy is the final velocity at a given instant of a time t, uy is the initial velocity, and minus g into t. v square is equal to u square plus 2as. That also gives us the final velocity, which in form of a vertical motion we can write vy square is equal to uy square minus 2gy. These are the kinematic equation of the ball or the projectile which is launched. This is a kinematic equation of the projectile which is launched in a vertically upward direction. Now suppose student, if I launch the object in a horizontal direction, for that again I consider xy coordinate system. Here I launch the object from 1 meter. At this position, I launch the object horizontally with the initial velocity ux bar. At every position, you can see the weight or the gravitational force act on the ball in a vertically downward direction. So that we can write the motion of a projectile is parallel to x-axis. So the equation of motion y is equal to 0. As you can observe here, student, there is no component of a velocity in the vertical direction. As we know, the gravitational force acts only in a vertical downward direction. But as there is no any component of a velocity in the vertical direction, there is no acceleration can possible in the case of the horizontal motion of the object. So that I can write the horizontal acceleration of the projectile or the ball is equal to 0. So that again there is no any external force which is act on the ball. I can write the net force which act on the projectile which is thrown horizontally is summation fx is equal to 0. So the horizontal motion of the projectile is also called as the motion in equilibrium. So you may ask me, if there is no any force which is act on the projectile, still how can it be moved? Remember student, force is not required to keep the body in motion. It is required to accelerate the body. So when there is no any force act on the body and body is in equilibrium, then the projectile moves by its own inertia. So it is the inertial force which make the projectile moves horizontally. Therefore, I can use here also the kinematic equation by considering the horizontal acceleration ax is equal to 0. In this case, for any instant of a time, I can find the position of the projectile by using the kinematic equation s is equal to ut plus half at square. For a given time t, I substitute for s as x and the initial velocity as ux into t. As the acceleration is 0, half at square part will be 0. Similarly, I can have Vx is equal to Ux. It means here you have to note down student the initial velocity and the final velocity or the velocity after any interval of time always remain constant, which is again I can show over here Vx square is equal to Ux square. Now here we understand both these vertical as well as the horizontal motions are independent of each other, even though both the motion happens under gravity. But there is a one motion which have a combination of these two motion, and that motion is the projectile motion. The projectile motion is the combination of independent vertical and the horizontal motion. Let's understand how. Let a football player kicks a ball with the initial velocity u bar, where the u bar is the initial velocity of projection. Theta is the angle of projection. Now let's resolve the initial velocity. Here you have a horizontal component of a velocity as a ux and the vertical component of a velocity as a uy. As we already know student, even though student, the projectile motion is the combination of vertical as well as the horizontal motion, but both these motion are independent of each other. So that at any random instant of a time, if I observe the velocity, Let that velocity be u dash. This u dash velocity at this given instant of a time is less than the initial velocity. This change in the resultant of a velocity is because of the change in the vertical component of a velocity. Because of the gravitational force, which is act vertically downward, try to decrease the upward velocity of the projectile. So at the given instant, you can see, student, the vertical component of the velocity decrease. And because of this change in the vertical component of velocity, there is a change in the resultant velocity u dash. As the horizontal component of a velocity ux is a remain constant, because there is no any external force which accelerate the horizontal motion of the projectile. This horizontal motion is because of its own inertia. So when the ball reaches to its maximum value, the vertical component of velocity becomes zero. So only component which is act on the projectile is the horizontal component. And this horizontal component, as you can see, student, at every position having the same magnitude as well as the same direction. At the maximum height, the resultant velocity is equal to the horizontal component of the velocity. When balls start moving in a downward direction, it observes that the horizontal component of velocity still remains same, but the vertical component of velocity changes its direction. Here you again observe, student, the velocity of the vertical component go on increasing. As the motion of the projectile is under gravitational force, which is the conservative force, so at the same height, the projectile has same velocity. So when the object reached to the vertical position from where it launched, it observed that it attained the same velocity as per the initial velocity. From this, we can say, student, a projectile is any object that once projected or dropped continues in a motion by its own inertia and is influenced only by the downward force of gravity. Now from diagram, I can write, student, the ux, that is the horizontal component of velocity, equal to u cos theta, where the theta is the angle of projection, and the uy, that is a vertical component of velocity, is equal to u into sine theta. The resultant of these two velocity is given by u is equal to under root of ux square plus uy square. The horizontal acceleration of the projectile is 0 and the vertical acceleration of the projectile is a minus g. Now let's suppose that at any instant of a time, the velocity attained by the projectile is a v bar. When I resolve this velocity, I have a horizontal component ux bar and the vertical component as a v by bar. Here I keep the ux bar as it is because I already know, student, that the horizontal component of a velocity because the horizontal component of velocity remain constant, it never change its magnitude as well as the direction throughout its motion. So I can rewrite the kinematic equation for the vertical and the horizontal motion. Now let's first write for the horizontal motion. For the horizontal component, we can write the initial velocity ux is equal to u cos theta and x is equal to 0. Here I can write wherever the s is present, for the displacement I write x, and for the initial velocity I write u cos theta. When I substitute the value, I have the following equation. Similarly, by using the condition as uy is equal to u sine theta and ay is equal to minus g, and I substitute these value in the kinematic equation, I have the equation of the vertical motion for the projectile is the following equations. Here the resultant velocity v is equal to under root of ux square plus vy square. Remember student, here I use symbol ux for the horizontal component of velocity in order to show you that the horizontal component of a velocity remains same throughout its motion. Now, brain gym for you. What is the trajectory of the projectile if the projectile is thrown from very high height from the surface of the earth? Think and answer in a comment box. Students, do like, share and subscribe my channel. Thank you.